Carrying on with ET55, 14th of November 2015, we are going to do question 3 in the maths for this one. A new 3-phase water heater has been installed in an industrial installation to replace an existing water heater. The water heater has 3 elements rated at 400 volts, each with a resistance of 30 ohms. The elements can be connected in either star or delta. Use the information in the introduction to this question to answer parts 3A and 3B. Calculate the power consumed by the water heater when the elements are connected in star. Okay, so we have 3 elements connected in star. Each of them are 30 ohms, 30 ohms, 30 ohms. We have our voltages coming along. And between here we have our 400 volts. Between here and here we have our 400 over square root of 3 volts, which equals roughly 230, but divided by so 230.94. Now, if we've got 230.94 volts across 30 ohms, we then get that divided by 30, and that equals 7.698, so 7.7 amps when rounding up. Now, they asked us for the power consumed. So power equals root 3 times V line times I line. We now have root 3 times our V line, 400, times our I line, 7.7, and now we can calculate our final thing. So times by 400 times by square root of 3. Using my already in calculator 7.69, and we get 5333.3 recurring watts. Now, if we look at the answer sheet, you will see that they have 5307. It is close, but it is not quite the same, and that is because they have rounded as they've gone through. It will be the same in your exam, which is why they have a tolerance for rounding. You can be out by almost 5% and it's still accepted, or I think it is 5%. Now, that is the first question complete, or I. Now, we've got I. Select the minimum size final subcircuit TPS cable that can supply the water heater when the elements are connected in star. Being that it is only pulling 7.7 amps, you can run that in a 1.5 mil. It could still handle it, unless you're in a domestic situation, because that will be derated. However, they mentioned that it's installed in an industrial situation, so insulation and derating is not a problem. You can easily put 10 amps on a 1.5. Now, question 3, select the minimum HRC fuses that can protect the final subcircuits connected in AII for the water heater when the elements are connected in star. We only need a 10 amp because we are handling 7.7 amps. So the next page. Next page is 3 continued. Cool. So our next question is calculate the power consumed when it is in star. Sorry, when it is in delta. And this one is a very simple one because we have P delta equals 3P star. So all we have to do is triple our 5333.3 recurring. So, and we get 16,000 watts or 16 kilowatts. 4-mark question, really quick answer. There are obviously other ways to do this if you were going in the reverse order of working this out. So we have delta connection, 30 ohms, 400 volts. Now, we want to know the current going through there. That is 400 divided by 30 equals our I phase. So 400 divided by 30, and we end up with 13.33, or 3 recurrent amps. Now, to get the line current, we actually have to multiply that by the square root of 3, which gives us 23.09 amps down our line. Now our power equals √3 times V line times I line. So with my value that I've still got in the calculator, which is my I line, I can multiply that by 400 and then multiply that by square root of 3, and I get 16,000 watts. Two different ways, exactly the same answer. If we look at the model answers, we get 16,003 watts. That is because they rounded up in the middle of the question. Now, our next question is state the minimum size final sub-circuit TPS cable that the water elements can be done when in delta, being that it is a 23.05 amp line cable. You could do that on a 2.5 as long as it's not too long. I would actually be more inclined to do it 4 mil in an industrial situation. Depends on the distance and the volt drop for that. The next question I have is what are the minimum size sub-circuits for that, and we could go for a 25 amps because that is the next size up. That is bigger than our line current.